So we're going to look at C and D in class, but I want to move on to looking at an exponential equation where we have E. We have some steps here for that. We're going to get E by itself first. So we'll treat it as a blob first, get it by itself. And then to undo E to a power, what we're going to do is take the ln of both sides. So just like the other type of problem, we used E to cancel out ln. Now we're going to use ln to cancel out E. So let's get going with this guy. So 4 e to the 2x power plus 2 is equal to 16. What we want to do is subtract 2 from both sides because this is our blob that we're trying to get by itself first. So cancel, cancel. And then we'll get 14. Now to get E by itself, it's 4 times E to the 2x. So I'm going to divide by 4, divide by 4. We get E to the 2x is equal to 7/2. I kind of like keeping it as a fraction. And now this is what I'm talking about undoing E to a power with a variable. Before we had like E squared, that's just a number, but E to the 2x, I need to get that x out of the, from being an exponent. So I'll take ln of both sides. Basically, I'm making each of these go into our natural log function. The reason I'm doing that is because they cancel. ln of E from the top of our page, those two cancel, and we'll get 2x outside of the exponent now. But ln of 7/2 isn't something I do anything with. There's no variable there. There's no E to cancel it out, so I get 7/2. And then my last step, because x is not by itself, even though we wish it was, I've got a 2 here, 2 times x, so I divide by 2. So I'll get x is equal to ln 7/2, that whole thing divided by 2. And we'll plug these in to the calculator in class together. Okay, so that's actually the longest of the 4. Now these are going to be a little shorter because if I look at this example here, E is by itself already. So what I'm going to do is take the ln of both sides. So basically I'm like putting it in the natural log function. And if I do it to one side, I have to do it to the other. That's going to be the biggest thing we got to watch out for. So cancel, cancel. And x minus 2 is no longer an exponent. And ln of 12 is ln of 12. That's a decimal here. So we need to get x by itself. It's plus 2, and please do not add 2 to this natural log. ln of 12 is a decimal, and then what we're going to do is add 2 to that decimal, not to the 12. So this is our calculator ready form. Just like our last test, we have calculator ready form. The last 2, we got to get our E by itself. It looks like it's times 2, so I divide by 2 before doing anything else. And then I got to take, because E to the negative x, I need that x to go down. So I'm going to take the ln of both sides. So it's negative x, because the ln and the E cancel. And then it's ln of 10. And I just have to cancel that -1. So it's -1 in front of x. So divide by -1, divide by -1. Calculator ready form for this would be negative ln of 10. So there are going to be 2 parts. Calculator ready form, so this, and then whatever you get when you plug it into the calculator. Last one. E to 3x has a plus 5 there to undo it. undo addition, I need to subtract. And then once this guy's by itself, that's when I can take the ln of both sides. So I'm taking, because e to the 3x, the variable's an exponent here, so I take the ln of both sides. The reason I do that is so it cancel. And I get 3x is equal to the ln of 10. Get x by itself, I divide by 3, and now x is equal to ln of 10 divided by 3. Or you could write it as 1/3 ln of 10. Both work. That's it for the natural log.